Today's lesson, we're going to look at quadratic functions in factored form. And the purpose of the first two questions is just to get us thinking about the vocabulary, so thinking about factors. So number one, what is the other factor of 6 if one of the factors is 2? So I think that's review for most of us. So the answer obviously is 3, because 2 times 3 equals 6. So we're thinking of things that multiply are factors. So in mathematics, what is a factor? So there's a few ways of describing that. One, we can talk about things that multiply to be something else, so that's called a product. So we can write that down. So numbers that multiply to be a product. And there's some certainly some other things we can say. We can say it's a number. If we divide it into another number, it divides without a remainder. So that's another way of kind of thinking about it. But really, when you think about factors, I guess for today's lesson would be helpful is to think about things that multiply together to equal a product. The point of number 3 is for us just to review graphing. Now, when we graph, we could really graph anything as long as we just plug in points. The goal of this lesson, though, is to learn some shortcuts of those characteristics that we talked about last class. Those characteristics will be shortcuts for us. But for this one, we're going to do it kind of the long way. So I apologize. This will take a little bit of work. So that first one, so if we just plug in -2 wherever we see an x, and then we'll just simplify that expression and plot our points. So that is -1 times -5. So f of -2 equals 5. And so we go over -2 and up 5. All right, the next number we'll plug in is -1. And so we can graph anything as long as we plug in enough points so that we see a pattern. So -1 plus 1 is 0. And then times -4, and anything times 0 is 0. So another point here is -1, 0. Okay. And we should take special interest to that one. That's one of our key characteristics. That is an x-intercept because our output is 0. All right, so our next one, f of 0. And this is another key characteristic because whenever we plug in 0, that is in y-intercept. Okay, we'll simplify that expression and we get -3. So again, on these ones here, f of 0 equals -3. And again, these are points, 0, -3. So there is that one right there. All right, and we'll continue on plugging these in. The next one, let's do f of 1. So when we plug in 1, we get 2 times -2, which is -4. So when we plugged in 1, we got -4. All right, we'll plug in 2. So that's 3 times -1. So that point is when we plug in 2, we get -3. And so right away we saw our function decreasing, right? It was going down, 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 and all of a sudden it came back up. So again, reviewing that vocabulary for last lesson, that is your that is your vertex, because it was that previous point because it turned around. So we could finish this out by just mirroring things over, but we'll go ahead and plug in 3. And the point of this problem is, again, to look at some shortcuts on these. And so we see a shortcut right here. So again, we have that x-intercept. All right, so let's analyze some of those key characteristics and then see how we can use the equation instead of table to come up with those. So what are the x-intercepts? So the x-intercepts are -1, 0 and 3, 0. And what is the y value in the x-intercepts? That's when it's the y value is 0. So that is our output. Okay, so so the next question, when x equals -1, why is the output 0? And really the key on that is one of the factors equals 0. And it's really, in this one, our first factor. So it doesn't matter which one. So when we did -1 plus 1, we got 0. And then 0 times anything equals 0. So we're going to use that key fact as a shortcut for us. So when we start looking at these intercepts. All right, so again, we're going to reflect on that information. So number 4, the value of r such that f of r equals 0, then r is called a 0. Often that number is the x-intercept. The distinction between zeros and x-intercepts, we'll talk about that later. So you can kind of think of those as the same thing. So it says state if 7 is a 0 of the function. So if we plug in 7, do we get an answer of 0? All right, so that's what, -3 times 14, and the answer is no. That will not equals 0. We'll continue with that reflection of factors equals 0. So number 5, find the number in the blank to make the equation true. So something times 3 equals 0. So that has to be 0. Number 6, same idea. Find the number in the blank to make the equation true. So 2 times something equals 0. Well, that one will have to be 0. So again, the idea behind 5 and 6 is if a factor equals 0, then the product equals 0. Okay, so again, notice it's a factor, not necessarily the variable. So number 7, find the value of a for the equation f of a equals 0. So 5 times a, so 5 times something has to equal 0. Well, a will have to be 0. Okay, so we're going to use that information to help us out find our x-intercepts. Number 8, if the product equals 0, then one of the factors must be 0. Again, one of the factors, not x. Okay, and that is called the zero product property. So if we have an equation a times b equals 0, then either a will equal 0 or b will equal 0. So the zero product property can be used to find zeros and find x-intercepts when the function is in factored form. So look at the problem there. Find the x-intercepts and show your work. Okay, so x-intercepts, first of all, is when our output is 0. So f of x is our output. So that's going to be our first step of saying our y value or output equals 0. So remember, whenever you see f of x, you can think of just y. Okay, so that's our first thing. Now we're going to use the zero product property to separate those two. And we're going to go ahead and say that first factor, let's say that is equal to 0, or our second factor equals 0. And if either one of those is true, then the entire product is 0, and again, that's our x-intercept. So we'll solve this like we would normally. So we'd add 24 on both sides, and then divide by 6. Same thing on this one, add 2, and then divide by 3. Okay, so as a point, that would be 4, 0 is one of our x-intercepts, and 2/3 0 is our other intercept. All right, so on the next page, we looked at this table here summarizes those 5 characteristics we looked at last class, but now we're thinking about an equation. So that equation right there is f of x equals some number a, and then x minus r1 times x minus r2. So whenever we're going to really analyze those 3 numbers right there. So how do you find the x-intercepts? We just reviewed that. You're going to set each product with a variable equal to 0, and then you're going to solve those. Okay, so each of those factors. Now the other parts we got to think about a little bit more. So how are we going to find the axis of symmetry? The axis of symmetry is always halfway in between the x-intercepts, always. So if we know the x-intercepts, we can just go halfway. So how do we find halfway? So this is halfway right here. Halfway, we're just going to average. So we take those two x-intercepts, add them together, and divide by 2. From there, if you're asked to find the vertex, we always have to know the axis of symmetry first. So substitute the x value of the axis symmetry into the function, and then you get the y value. Fourth characteristic, y-intercept, you always plug in 0 to get the y-intercept. And concaved up or concave down, it has to do with that a value out in front. So if a is greater than 0, in other words, if a is positive, it'll be concaved up, and therefore the vertex is a minimum. If a is negative, then the graph is concave down, and the vertex is a maximum. All right, so let's apply that information to number 9. So we're going to go ahead and graph this just like we did on question number 3, but we're going to do it by just our shortcuts, okay? So we're not going to use a table. So first thing we're going to do is find the x-intercept. So every expression that has an x in it, so we're going to set that equal to 0, because really x-intercepts, I should probably put 0 here first. So x-intercept means our output is 0. So what we're going to do is take each of these, so x minus 5, and say either that's 0 or the second one right here, x minus 3 equals 0. Now in these ones, I guess we can do in our heads and say that's got to be 5, and this one 3 minus 3 is 0. But really on harder algebraic ones, you may have to do plus 3 and solve it algebraically if you can't do it in your head. Okay, so let's go ahead and plot those 2 points. So at 5, 0. And x equals 3. Okay, so those are our x-intercepts. The y-intercept, we're going to plug in 0. So we're going to copy that top equation. Wherever we see an x, we're going to put a 0. Okay, so this is -6 times -5 times -3. So we just multiply those. -6 times -5 is positive 30, and then 30 times -3 is -90. So obviously that one will not fit on our graph here. All right, concavity, that is where we are going to look at that number right out in front. If there's no number there, then it's 1, and so it'll be positive. So this one, that a value is negative, so it's going to be concave down. Okay, so it's going to have this type of shape. Part D, axis of symmetry, and this is where you really need to connect A and D together. Okay, so these two are kind of related. Again, they're halfway. If you look at their graph, you could just visualize it, right? Halfway between 3 and 5 is 4. But for the sake of just understanding how to do this problem, let's go ahead for harder ones and say, all right, that line is going to be the x-intercepts, so 5 and 3. We're going to add those together and divide by 2. So that's 8 over 2, which is 4. Again, that should make sense. So that, again, there's that line of symmetry that the graph mirrors over. All right, vertex, again, you got to connect these two right here. Okay, on the vertex, we already know half of the answer. It's on the axis of symmetry, so this is going to happen already. So we just have to find the y value. And so again, how do we find y values? We're just going to plug in x. So we're going to plug in 4. So 4 minus 5 and 4 minus 3. So we have -6 times -1 times +1. Okay, and when we multiply those, we get a +6. Okay, so our vertex, our turnaround point, is over 4 and up 6. All right, and if we just get those 3 points, that is sufficient for graphing these. Okay, so we know the turnaround point, that's kind of key, and we know where it goes to the x-axis. So if we just get those 3, we are set. Let me clean up that part. All right, so if we, again, let me summarize. If you get that part down for this lesson, you are set. To find the x-intercepts, set each factor equal to 0. Y-intercept, you plug in 0. Concavity, you look at that a value. Okay, so if it's negative, it's down. Positive, it's up. Axis of symmetry is always halfway in between the x-intercepts, so make sure you really get that down. And then the vertex, you just plug in the axis of symmetry into the function. All right. Now f is a transition statement to another idea, so I give you a different function. So notice if you'd compare the two equations on these, that would probably be helpful. So on this one, everything's the same. We have the same factors on those. What's different though is that a value is a little bit different. Okay, so if we look at these, we should have when will that factor equal 0? When x is 5. right? And then when is this factor equal 0? When x is 3. So these are going to share the same x-intercepts. What's going to be different about this is the vertex, because again, halfway in between those is the same axis of symmetry. Okay, so that does not change. So the x-intercepts are the same. The axis of symmetry is the same. That's at x equals 4. So what's going to be different is our vertex, that turnaround point. So all we have to do is plug in that number 4. So we're going to plug that in. So it's -2, 4 minus 5, and 4 minus 3. So that's -2 times -1 times +1. Okay, so on that one, we multiply those. When we plug in 4, we get 2. So that's our turnaround point. Okay, now, so if we were to kind of compare these, we'll notice that the only difference between those is, again, well, the major difference is that turnaround point. Okay. Now, one of the graph will be skinnier than the other. We'll talk about that more another time, but again, they share the same x-intercepts because they have the same factors. All right, number 10, that'll be our last one that we need to do. John kicks a ball 40 feet. It reaches a height of 20 feet, so that's the highest. Write a quadratic function to represent the height of the ball as a function of its distance. So if we just think about a graph here, and the ball starts right here, and it is kicked, all right, and it goes 40 feet. Okay, so if we look at that, and it's going to go in a quadratic formula. So we just thought I'd think about the x-intercept. So that x-intercept is x equals 0, and x equals 40. Okay, so if we're using that function from before, we have some number a, and then those numbers right here is going to be x minus 0, and then x minus 40. Okay, so because if x equals 40 is an intercept, that means because one of the factors was actually x minus 40. Okay, and then we should get that relationship between those two. All right, so we have 2 out of the 3 numbers, right? We knew both of those numbers right there, so it's always minus whatever the x-intercept is. So our only thing we have to do now is find that a value. Okay, now remember, f of x, that's the same thing as y. So let me simplify this. So this is times x and x minus 40. All right, so for us to find the a value, we have to plug in a point, and then we'll be able to algebraically solve for that. So let's go ahead, and that's where we're going to look at this part right here. So what is the height? The height is 20. And when does it get that height of 20? The height of 20 is going to be halfway, exactly halfway in between those two. So that point right there is halfway in between 0 and 40 is 20 with a height of 20. So we'll go ahead and plug those in. So the y value there is 20. We don't know what a is. Our input is 20 for our x's. All right, so let's go ahead and simplify that. And then 20 minus 40 is -20. We'll simplify that some more. So 20 times -20 is -400 times a. All right, and algebraically, we're just going to divide since we're multiplying, and we'll simplify that. So a is, we'll get rid of those, and that's -120. Okay, so that helps us find out that a value, and we'll just substitute that a value back right up into there. So 20, one of the factors is x, and the other one is x minus 40. So that's kind of how some of those equations come up. All right, the next ones will just be practice, same idea. If you understood the previous ones, you are good. So the x-intercepts, that's when our output is 0. Now that 2 out in front we can ignore or keep it with 2 times x. So 2x equals 0 and x plus 2 equals 0. So we'll set both of those factors equal to 0. So the first one is 0, and on this one we'll subtract 2. So x equals -2. So one of the intercepts 0, and the other one is -2. All right, the y-intercept, that is when x is 0. So we'll plug in 0 here. All right, and we actually get 0. 2 times 0. So the x-intercept and the y-intercept are the same. concavity, we'll look at that one. So we look at that number out in front that we're multiplying the whole thing by. That is positive, so that is going to be concaved up. All right, the axis symmetry is halfway in between the x-intercepts. So the x-intercepts are 0 and -2. So halfway in between those is -1. That should make sense if that's our axis of symmetry. Again, algebraically, you may have to do some problems algebraically. So you add and divide by 2. So that's another way of getting a 1. All right, the vertex, it's always -1. Or excuse me, on this problem, it's the same as the axis symmetry. Those will always match, so you just plug that into our function. Yep, and so that is going to be 2 times -1 is -2 times +1, so that is -2. And that is sufficient for our graphs for today. If we get those x-intercepts, we are set. All right, and the last problem, we're just analyzing these. We should make sense of these. Okay, so on this one, let's identify the x-intercept. So right there, that x-intercept is x equals 3. So how did we get that? It's because one of the factors is x minus 3. And on the other side, that right there, that is -1, 0. So how did we get -1? It's because we had x plus 1. So there's always going to be opposite, because when we do x plus 1 equals 0, when we solve for that by taking that inverse, that's how we get -1. Same thing on the other one. We have x minus 3. Okay, when we add 3, we do the inverse. That gives us the x-intercept. So right away, we can look at for the factors, where is the x plus 1 on those ones? So that's got to be one of these two over here. It's not x minus 1, so we can get rid of those. All right, and C and D, they both have a factor of x minus 3. So the next part we have to look at is just this number out in front. Okay, so this is -1, this is +1. This would be concave down, and this one is up. So our graph is concave down, so that is C. So again, for this lesson, if we get down how to find x-intercepts, axis of symmetry, and the vertex, I think we're set.